So we're first going to go over kind of review from last class, just how we calculate these elasticities, and also try to give a glimpse as to why they matter for revenue. So we talked about elasticity, how to calculate it, but any one demand curve doesn't have the same elasticity over the entire demand curve. It depends on where we're at in terms of quantity. So I started this and messed my video up, so I didn't want to redraw. But the first thing we're going to do is let's assume that we're moving from a quantity of 0 to a quantity of 1, right? This is the portion of the demand curve that we're on. Let's find its elasticity. Well, if we recall from last class, the elasticity of demand is the percent change in quantity demand over the percent change in price. And we're going to find these percent changes using the midpoint method. So the midpoint method says take the difference in quantity and divide it by the average of those two quantities. So for us, right, our quantities were 1, 0, right? We're going from 0 to 1, so we'll take the new quantity minus the old, divided by kind of our average quantity. Well, from 0 to 1, right, the average would be 0 plus 1 divided by 2. This is just going to be our numerator. I'm writing a little bit big, so it's why it kind of doesn't quite line up. So this up here represents our percentage change in quantity demand. Then down here in the denominator, we need our percentage change in price. So we'll look at the difference in price. So we went from 10 to 9. So take the new price minus the old, right? Divided by our average price. So add those two up, divide by 2. And this is our percentage change in that price, okay? So the percentage change in quantity demanded here, we end up with 2. Right? And then the percentage change, and when I say 2 here, right? And then I have the percentage change in price in my denominator. That percentage change in price would be something like approximately 0.1. There's more decimals, right? So you can see here, we're going to get an elasticity of demand of 20. So very, very high, right? And that makes sense, right? The percent change in price was relatively small, right? If you don't want to think about the midpoint method, falling from 10 to 9 was like just cutting out 10%. However, the change in quantity demanded, it's almost like if we don't use the midpoint method, going from 0 to 1 is actually like an infinite percent increase. So this small percent change in price caused a huge percentage increase in demand. Now notice, the units of how much they change are the same, 1 and 1, but the percent change in quantity demanded was much higher than the percent change in price. So here we would say that we're on kind of an elastic portion of the demand curve, right? That elasticity is greater than 1. We talked about that last class. We do the exact same thing down here at this point in the demand curve, but basically everything's flipped, right? It's the same values. I kept those the same for, to make it easier. But now my percentage change in quantity demanded, right, going from 10 to 9, my percentage change in quantity demanded down here is going to be that 0.1 divided by that percentage change in price, right? That's going to be, well, now price is going from 1 to 0. So that percentage change that we found before for quantity demanded will now be the percentage change we see in price because the numbers were the same. So 0.1 over 2 is 0.02, much less than 1. So we say down here, we're on the inelastic portion of our demand curve. Okay. So a little bit of review there. The next thing I want to make sure we get a glimpse at before next class is notice when I was going from 10 to 9 units, right? Let's think about total revenue there. So total revenue, and we'll keep this as the kind of red will represent kind of our elastic. So total revenue started at $0, right? When we were selling a quantity of 0, total revenue is 0 because total revenue is simply price times quantity. So we started out originally at a price of 10, we sold 0, our total revenue is 0. When we then move down, we decrease our price. Well, now the price is 9, and we're selling 1 unit. Notice total revenue has gone up, okay? However, if we look over here on the inelastic portion, right, so we'll use kind of blue to represent that. So when we have an elastic point on the demand curve, when we decrease the price, we actually get total revenue increases. However, when we're on the inelastic portion, right, which was at quantity of 9, well, here, total revenue, originally I was selling 9 units at $1, right? I think, sorry, I flipped that. Price should have been $1 quantity, but it doesn't matter the the direction. It's price times quantity or quantity times price. So we've got total revenue 9. Then when I move to this new point, my total revenue, well, now the price is 0, right? If the price was 0, I'd sell 10 units, but my total revenue is 0 because I'm not making anything by selling them. So we can see when we're on the inelastic portion of our demand curve, if we continue to lower the price, our total revenue decreased. Whereas when we're on the elastic portion of our demand curve, as we lowered the price, our total revenue actually went up, right, from 0 to 9. So we'll cover this more in class, but this is kind of our first look at these